Let's look at similar equations except using other trig functions, functions other than sine and cosine. In this instance, we have negative 2 cosecant theta minus 8 equals negative 12. So it's just like a linear equation would be. If we think back to the good old days when we had nice easy problems, we might see negative 2x minus 8 equals negative 12. And just like we would solve this for x, we're going to solve this equation, negative 2 cosecant theta minus 8 equals negative 12. We're going to solve that for cosecant theta, and then we'll go from there. So linear equations, I would start by adding 8 to both sides, giving me negative 2 cosecant theta equals negative 4. Then I would divide both sides by negative 2, giving me cosecant theta equals 2. Alright, now where do we go from here? Well, we know that cosecant theta is the reciprocal of sine. So if cosecant is 2, then that would mean sine theta, which is the reciprocal of cosecant, would be the reciprocal of 2, or 1/2. So it gives us sine theta is 1/2. Now we can go from here, look at our unit circle. Sine is our y value. We want to know where our y value is 1/2. So that would be here and here. Those are the 2 points where our y value is positive 1/2, and that corresponds to pi over 6 and 5 pi over 6. So that gives us theta equals pi over 6 and 5 pi over 6. And again, I'm not using the plus 2 pi n because we're only looking for angles within the first rotation of the unit circle. Let's move down to another example. Negative 5 square root of 3 cotangent theta plus 1 equals 16. Well, this is a mess. And one additional change we've got here is we're looking for theta in degrees this time. So that's a little bit of a switch. Solving this, just as we would any other linear, we'll subtract 1 from both sides, giving us negative 5 square root of 3 cotangent theta equals 15. Then we'll divide both sides by negative 5 square root of 3, gives me cotangent theta equals 15 over negative 5 square root of 3. We can divide the numerator and denominator by 5, giving us cotangent theta equals negative square root of 3, gives us negative 3 over the square root of 3. And I could simplify this a little bit further, but cotangent is the reciprocal of tangent. So I'm going to end up using reciprocals anyway. I'm going to leave it the way it is right now. So I've solved this for cotangent theta. I know cotangent theta is something. That also tells me that the reciprocal of cotangent, which is tangent theta, will be the reciprocal of 3 over the square root of 3. So that's going to be negative square root of 3 over 3. Now I need to think about my unit circle. Where is tangent going to be the square root of 3 over 3? And the reference angle, where tangent is the square root of 3 over 3, is going to be at 30 degrees. So that gives me my reference angle. Now let's figure out what my actual angles are. Tangent is negative in the second and fourth quadrants, so I need an angle with a reference angle of 30 degrees that's in the second quadrant. And a reference angle of 30 degrees in the second quadrant corresponds to an angle of 150 degrees. I also need an angle in the fourth quadrant with a reference angle of 30 degrees, and that would correspond to 330 degrees. So in this case, the solutions that come from this equation are theta equals 150 degrees and or 330 degrees. Alright, this one's a little more challenging. Cosecant x equals negative 117.3. That is, well, that's just kind of nasty. We can just write off, we know that cosecant's the reciprocal of sine, so we can say that that means that sine of x is equal to the reciprocal of 117.3, negative. Now, we don't have anywhere on the unit circle that works for this. This is just an ugly thing. So we're going to have to use our calculator to calculate this. So I'm going to start off by saying that my reference angle, x, is going to be the inverse sine of negative 1 over 117.3. So let's bring up a calculator. I am in radians, so let's make sure we're there first. I am not, so let's go to radians. And now I'm going to say inverse sine of negative 1 over 117.3. Now 1 over 117.3 is going to be a pretty small number, so this is going to be close to the inverse sine of 0, which means it's going to be a smaller angle. It'll be somewhere closer to 0. Let's hit enter. And we get a radian reference angle of negative 0.008525. And always watch and see where you're told to round to when you enter your answers. This one's probably going to be around to 4 digits, but I wanted to throw in the extra ones to start with. Now, this is an angle in radians, but it is not in our range that we were given, the 0 to 2 pi. So let's do a little thinking about this. Let's put it in standard position. So this is this angle right here. So if we want to put this between 0 and 2 pi, we need to add 2 pi to that. So that's easy. We'll just hit plus 2 pi. And that gives us an angle of 6.2746601. This is one of our angles. This is the other way of looking at a coterminal angle to the one we got out of our calculator. However, there is another angle on the unit circle where this will be true, where sine of the angle will be negative 1 over 117.3. So let's think about where sine is negative. Sine is negative in the 4th quadrant and the 3rd quadrant. So we need to come up with an angle over here that has that same reference angle, 0.008525, but is between 0 and 2 pi. Well, if this angle is pi, we can add pi to 0.008525, and that will give us our angle. So 0.008525 plus pi equals, and our second angle is going to be 3.150012. We'll round both of these to 4 digits just for brevity's sake, so that gives us two answers. X equals 3.1500 and x equals 6.2747. And those will be our answers. One last question. This one's also going to require us to use a calculator. Secant theta plus 5.954 equals 0. Alright. Like any other linear based equation, we're going to go ahead and solve this for secant theta. That gives us secant theta equals negative 5.954. And because we know that secant is a reciprocal of cosine, that means cosine theta is going to be the reciprocal of 5.954. So in order to get our starting point, we need to plug into our calculator what is inverse cosine or arc cosine of negative 1 over 5.954. And that'll give us an angle. Then we'll have to play with it a little to make sure we get all of the correct angles and that they're in the right places. I notice that this is in degrees, so let's change our mode to degrees. And now let's find inverse cosine of negative 1 divided by 5.954. That gives me an angle of 99.6688999. Let's call it 99.67 degrees. Again, use the instructions for your rounding. Now that tells me of an angle, about here, for which this is true. And that is within the range 0 to 360. But we also know it happens more than once. It happens in another angle, at another place on the unit circle. So let's look at where cosine is negative. Cosine is negative in quadrant 2 and quadrant 3. So we need an angle down here that has this same reference angle. Sometimes we call the reference angle alpha. So we need that same reference angle down here. So what I can do is find the difference between 180 and 99.67. That'll be my reference angle here. So 180 minus 99.67 equals, it gives me a reference angle of 80.33 degrees. An angle in the third quadrant with that same reference angle would then be 180 plus that new reference angle, 80.33. And that gives us, I missed a 3 on there. We know that's 260 degrees, 0.33 degrees. So those are my two angles within the first cycle of the unit circle in standard position for which this equation holds true. Theta equals 99.67 and theta equals 260.33 degrees.